Hello everyone! Today I'm going to talk about the one proportion z-test. This is one of the many hypothesis tests you will come across in a statistics course. The best way to show how to do this is by starting with an example. Here's the problem. A company claims that 72% of their customers are satisfied with their product. Random sample of 200 customers shows that only 65% are satisfied. Test the company's claim. Anytime a problem says test the claim or is there enough evidence, you know they will be doing a hypothesis test. They all start the same way. You have to name the test. Anytime there are percentages in the problem, you know it will be one of the proportions tests. Now, even though you see two percentages, this is not a two proportions test because we aren't comparing two populations. It doesn't say males had this much and females had this much. These numbers apply to the same study. That means it is a one proportion z-test. We write z-test because we will be working with the normal distribution. The next step is to check the conditions. If one of the conditions is not met, we cannot perform the test. The first condition we must check is that it must be a simple random sample. A simple random sample helps eliminate any bias, so it is important that we check the data is random. It says in the problem, a random sample was taken, so we can say this assumption is given. The next condition is the population must be more than 10 times the sample size. This is what makes it independent. It's easier to guarantee consistency when the observations are independent of each other. The problem says the sample was 200 customers times 10 is 2,000. Now, we don't know how many customers buy stuff from this particular company, but it's reasonable to assume that more than 2,000 customers go to this company, or at least purchase products from the company. If it's a large franchise like Walmart, many people go into that store and can buy items online as well. The last condition is the normal condition. This makes sure that we can use a normal distribution to solve. For proportions, the size of the sample, n, times the proportion, p, has to be greater than or equal to 10. And n times 1 minus p also has to be greater than 10. In this problem, n is 200, and our proportion is 0.72, since that's the original claim. This 65 doesn't matter right now. 200 times 0.72 is 144. That's greater than 10. 200 times 1 minus 0.72 is 56. That's also greater than 10. So this condition is met. You actually have to show the calculations. You can't just put a check mark next to the conditions. All of our conditions are met, so let's go on to the next step. Write the null and alternate hypothesis. The null is the common view, the claim, what we're trying to prove or disprove. It is expressed as h sub 0. The company claims that 72% are satisfied, so the null hypothesis is our proportion, p, equal to 0.72. The null always has an equal sign. The alternate hypothesis is expressed as h sub a. This is what we think is the real cause. The null and the alternate are the same except for the sign. The alternate can either have a greater than, a less than, or not equal to. If we look at our problem, it said random sample, 65% were satisfied. And since 65 is less than 72, our proportion is less than 72. We have to define what p means. In this context, p is the proportion of customers that are satisfied with the product. Now we are ready to solve. I'm going to do it by hand first, and then I'll teach you a shortcut. The first step is to calculate the z-score. The formula to find that is different from mean. It's p hat, let's make p hat. P hat, this is our sample proportion, minus p, our claimed proportion, divided by standard deviation. If you look at section 3 of the formula sheet, you see this formula is right here, the first one. To find standard deviation, we look at this formula, square root of p times 1 minus p divided by n, since we're dealing with sample proportions. Let's plug in all the information. P hat is 0.65 minus 0.72 divided by a square root of 0.72 times 1 minus 0.72 divided by 200. When you simplify, you should get z equals negative 2.205. Let's draw our normal curve to visualize. Remember, in the standard normal curve, the mean is 0 and the standard deviation is 1. We got a z-score of negative 2.205, which is about here. We said that we are trying to find less than, so let's shade to the left. Okay, let's solve this. Second vars, second one from the top, normal CDF. Since our bound is less than, we plug in a large negative number, negative 100. Our upper bound is our z-score, negative 2.205. You get this answer, which rounds to 0.014. This is our p-value, or our probability. Let's go back to the null and the alternate. Here's the z-score again, and here's the p-value. The null hypothesis, p equals 0.72, will be rejected if it is less than the significance level or the alpha level. The alpha level is usually 0.05, and it can also be 0.01. I'm going to make the alpha level 0.05. That's the symbol for alpha. If we look at our p-value, we can see that 0.014 is less than alpha, which means we reject the null hypothesis. Writing this in context, you would write, there is sufficient evidence to support the claim that less than 72% of customers were satisfied with the product. There is a 1.4 chance this result is due to random variation. This part puts the p-value in context. Now, what would happen if we made our alpha level 0.01? 0.014 is greater than our alpha, so that means we failed to reject the null. We don't ever want to say we fully accept the null because we don't have enough evidence to do that. The only difference between the sentences is now there is not sufficient evidence to support the claim. I'm going to show you a shortcut on the calculator that allows you to go straight to your p-value, and you don't have to do any of the calculations yourself. Hit Stat, scroll over to Tests. Since we are doing a 1 proportion z test, scroll down to number 5. This p sub 0, that is the number that was written in our null and our alternate hypothesis, 0.72. X is p hat, our sample proportion, 0.65, times the size of our sample, 200. If this number was a decimal, you'd have to round it to the nearest whole number. N is just the size of our sample, 200. Now, since our alternate said less than, we scroll over to less than, hit calculate. We get the same z-score and the same p-value that we got when we did it by hand. As long as you name the test, you can go straight to the calculator, and you don't have to show any of your work. You still have to write your z-score and your p-value though. That's all I have for today. Thanks for watching.